Good morning friends, I welcome you all at your favorite YouTube channel VIGYAN VIHAN. This is our problem solution series for General Aptitude Part A of UGC CSIR Net. In this video, we will solve problem number 11 to 15 of Mathematical Sciences paper of June 2017. The General Aptitude part plays a vital role in UGC CSIR Net paper. It consists 15% marks of the total marks of this paper. We will have to attempt only 15 problems out of 20 given problems in part A. That's an advantage for the candidates, and NET aspirant can easily select 15 easiest problems out of given 20 problems. So all the best for the exams. Let's start the solution. The first problem of this episode: a tight fitting band is wrapped around the equator. Another circular band whose length is 15 meters more lies at a certain height over the first band. A group of human beings attempt to pass under the longer band. Can they walk under it, where the Earth's circumference is roughly 40,000 kilometers? The height of human being is between 1 and 2 meters. Option 1, yes. Option 2, no. Option 3, cannot be determined. Option 4, only those with height less than 1.7 meter. This is our first problem, problem number 11. In this problem, a tight fitting band is wrapped around the equator. The equator of Earth is a kind of circular ring. Another circular band whose length is 15 meter more lies at certain height over the first band. In that condition, the equator is the inner circle. If we look from one pole, it may be North Pole. According to the given problem, Earth's circumference is roughly 40,000 kilometers. This is a circular ring, and its radius, if it is capital R, then the circumference of the Earth's equator is 2 pi capital R, which is nearly equal to 40,000 kilometers. Another circular band whose length is 15 meter more lies at certain height. If another band has its circumference 15 meter more, then if the normal distance between the Earth's equator and the above band is small h, then the height of the man which can pass under the upper band will be small h. The radius of the outer band would be capital R plus h. In that condition, 2 pi capital R plus h would be equals to 40,000 kilometer plus 15 meter. Here is first equation, here it is second equation. Now subtract the first equation from the second equation. We will get 2 pi small h will be equals to 15 meter. Now small h would be equal to 15 upon 2 pi in meter. Now 15 upon 2 pi, the pi value is approximately 3.14. So to multiply with 3.14, it will give you value in meter. This value 15 upon 6.28 in meter will be approximately equal to 2.6. Now, according to the given problem, the height of human being is between 1 meter and 2 meter. Then from the calculation, the distance between the Earth's equator and upper band would be equal to 2.6 meter. Then all the human being can pass under the above band. What question is asking? A group of human beings attempted to pass under the longer band. Can they walk under it? So the correct answer is yes. Option first, all the human beings can pass under the longer band. Friends, Problem number 12. L is the tallest and eldest of a group of 5 people K, L, M, N and P. M is elder to N and shorter than K. M and P are of same age and P is taller than K. N and K are of same height and K is younger to P. Which of the following inference is certain? Option 1. P is taller than M. Option 2. N is the youngest. Option 3. N is elder to P. Option 4. N is elder to K. Friends, here is the next problem. In this problem, there are certain conditions given for 5 people K, L, M, N and P for their age and their height. We will have to find out a certain inference out of the following 4 options. We will read the given conditions for the height of these 5 people and the age of the same people. Now, first condition is here. In starting, L is the tallest and eldest of a group. L is tallest and eldest. So, tallest. So, L is here for height, and for age, L is oldest or eldest of the group. M is elder to N for their ages. So, M may be here, N may be here in ages. The series here we are making like the lowest person, the lowest place is for the youngest person. In ascending order, their age is increasing. For height also the same condition. The shortest person will be at the downmost position. The taller person will be on the upper positions. So let's start. From the second condition, M is elder to N. We written here M is shorter than K. M is shorter than K. For height, M is shorter than K. From the third condition, M and P are of same age. So M and P are of same age. M age will be equal to P. So both will be at the same place in this table, and P is taller than K. P is taller than K. N and K are of same height. N and K are of same height. So K having the place here, N will also have the same place. Here are now 5 persons in respect of their height, but in age group there are only 4 persons. From the last condition, K is younger to P. K is younger to P. So K can be written here or here. In both conditions, K is younger to P. Now, read the given 4 options. We denote the first position of K by 1, the second position of K by 2. Read the options. P is taller than M. P is taller than M. Yes, P is taller than M. That is having a certain inference from the given conditions. So, option 1 must be the correct answer. Let's think about the remaining 3 options. Option 2, N is the youngest. Option 2, N is the youngest. For their age group, there are 2 conditions for K. These are possible from the given conditions. So, if K is having the position 2, then option 2 may not be correct. So, this inference may not be certain. Option 3, N is elder to P in their ages. N is elder to P in this option, but in fact n is younger to p. So option 3 also is not a certain inference from option 4. N is elder to k. If k is at second place, n is elder to k, but if k is at position 1, then n is younger than k. So option 4 also may not be correct answer of this problem. So the correct answer of this problem is option 1. P is taller than m. Okay. Problem number 13. If the product of three consecutive positive integers is equal to their sum, then what would be the sum of their squares? Option 1 9, option 2 14, option 3 16, option 4 24. Friends, here is the next problem, problem number 13. In this problem, if the product of three consecutive positive integers is equal to their sum. Now, let's assume these numbers are like n minus 1, the first integer, the next consecutive integer would be n, the third consecutive integer would be n plus 1. Now, the product of these integers would be n minus 1 multiply with n plus 1. That can be written as n multiply with n square minus 1. Now, the sum of these integers would be n minus 1 plus n plus n plus 1. That would be 3 of n. According to the given problem, for these three consecutive integers, the product of these integers would be equal to their sum. So, equating these two terms, n is equals to n square minus 1 is equals to 3n, we get this equation. We will have to solve this equation to get the value of n. The n value is not equal to 0 according to the given condition. These are positive integers. So, n is not equal to 0. In that condition, we can solve it like this: n square minus 1 would be equals to 3. Now, n square would be equals to 3 plus 1, that is now n square equal to 4. All these are positive integers, so we can write here the value of n is positive 2. Put the value of n, we will get the integers like 2 minus 1, 2 and 2 plus 1. These are 1, 2, 3. You can check your solution by multiplying these integers with each other. The product is 6. The sum of these integers will also be equal to 6. What question is asking? What would be the sum of their squares? So, the sum of their squares, the square of these terms would be 1 square, 2 square, 3 square. These are 1, 4, 9. Now, their sum would be equal to 1 plus 4 plus 9, that is 14. So, the correct answer of this problem is 14. That is option 2. Friends, problem number 14. A tall metal cylinder is filled end to end with small n snugly fitting spherical wax balls of diameter small d. If the balls melt completely, the volume fraction occupied by the melted wax is option 1 independent of both small d and small n, option 2 dependent on both small d and small n, option 3 independent of small d but dependent on small n, option 4 dependent on small d but independent of small n. Friends, here is the next problem. In this problem, a tall metal cylinder which is filled end to end with n snugly fitting spherical wax balls. So the number n of balls is a variable and the ball will have its diameter small d. So small d, the diameter of the ball, is also variable. These two variables are under consideration to find the correct answer of this problem. Question is asking, if the balls melt completely, the volume fraction occupied by the melted wax is. Question is asking the volume fraction of the balls with respect to the volume of the cylinder. Options are given as option 1, independent of both D and N, option 2, dependent on both D and N, option 3, independent of small d but dependent on N, option 4, dependent on D but independent of small n. We consider a cylinder whose diameter is not given, so I consider the diameter of the cylinder under consideration will have its diameter equal to the diameter of these wax balls. So the diameter of the wax ball is given as small d, so the same would be the diameter of the cylinder, which is denoted by capital D. Now this is the first lesson, capital D is equals to small d. This cylinder will have its height capital H. The cylinder is filled with small n number of balls which are tightly fitted inside this cylindrical can. In this condition, the height of the cylinder capital H will be equal to number of balls and multiple of the diameter small d of these spherical wax balls. This is first lesson, this is second lesson. Now the total volume of wax balls, which will be same after melting these balls or before melting these balls, that is n number of balls, multiply it with volume of a single ball, that is 4 by 3 pi. The radius of the spherical ball will be 4 by 3 pi r cube, so small d by 2 cube. Volume of the metal cylinder will be equal to pi radius square, that is here capital D by 2, or you can write using the relation first, 2 small d by 2 square, that is pi r square here, and its height, the height or length of the cylinder is small n, multiply with d. Now there are variable terms in the volume of wax balls, small n multiply with small d cube. In the volume of the cylinder, it consists the variable terms small n multiply with d square multiply with d, that is d cube. In the volume of wax balls, the constant terms would be pi by 6. In the volume of the cylinder, the constant term is pi upon 4. Using the both relations for the calculation of the fraction of total volume of wax balls with respect to the volume of the metal cylinder can be calculated. Pi by 6 n d cube, divide it by pi by 4 n d cube. The final value would be 4 by 6, that will give you the value, the fraction 2 by 3, that is a constant term. This formula was first discovered by the famous philosopher Archimedes? So, the correct answer of this problem is the volume fraction occupied by the melted wax is independent of both D and N. Option N. Friends, here is problem number 15. Some fishermen caught some fish. No one caught more than 20 fish. A1 number of fishermen caught at least one fish among them. A2 number of fishermen caught at least two fish among them, and so on. And A20 number of fishermen caught exactly 20 fish among them. How many fish were caught? Option 1, A1 plus A2 plus A3, so on, plus till A20. Option 2, A1 plus 2A2 plus 3A3 plus so on till 20A20. Option 3, 20 whole multiplied with A1 plus A2 plus A3 so on till A20. Option 4, 20 whole multiplied with A1 plus 2A2 plus 3A3 plus so on plus 20A20. Friends, here is the last problem of this episode, problem number 15. In this problem, some fishermen caught some fish. No one caught more than 20 fish. So number of fishes a fisherman can catch is from 1 to 20. That is 1, 2, 3, 4, so on, 19, 20, like this. If we assume N1 is number of fishermen who caught exactly one fish each, N2 is number of fishermen who caught exactly two fish each, N3 is number of fishermen who caught exactly three fish each, like this, then N20 number of fishermen who caught exactly 20 fishes. In that condition, question is saying that A20 is number of fishermen caught exactly 20 fish. In that condition, N20 would be equal to A20. Similarly, A19 would be the number of fishermen who caught at least 19 fishes. That means that is number of fishermen who caught 19 fish or 20 fish. So A19 would be equal to N19 plus N20. Now you can calculate easily the number of fishermen who caught exactly 19 fishes each, and 19 would be equal to A19 minus A20. Moving from the last term to initial terms, A18, the number of fishermen who caught at least 18 fishes would be equal to N18 plus N19 plus N20. In that condition, the number of fishermen who caught exactly 18 fishes can be calculated by A18 minus A19. So, N of 18 would be equal to A of 18 minus A of 19. Similarly, the number of fishermen who caught exactly 3 fish each can be calculated by the term A3 minus A4. N2 may be calculated by A2 minus A3. N1, the number of fishermen who caught exactly one fish each. N1 would be equal to A1 minus A2. There are given 4 options we will have to calculate how many fish were caught. So we will have to count the total number of fishes caught by these fishermen. Now you can understand it, and the series we will get the number of fishermen who caught only one fish each is N1. It can be calculated by A1 minus A2. So the total number of fishes caught by these fishermen would be equal to 1 multiplied with N1. So 1 multiplied with A1 minus A2. N2, the number of fishermen who caught exactly 2 fish each, would be calculated by A2 minus A3. So the number of fishes caught by the N2 number of fishermen would be calculated by 2 of N2, that is 2 multiplied with A2 minus A3. Similarly, N3, the number of fishermen who caught 3 fish each, will be calculated by A3 minus A4. So the total number of fishes caught by these fishermen will be 3 multiplied with N3. So 3 multiplied with A3 minus A4. Similarly, for higher terms, N19 would be equal to A19 minus A20. N19 is the number of fishermen who caught exactly 19 fishes each. So the total number of fishes caught by these fishermen is equal to 19 multiplied with N19, that is 19 multiplied with A19 minus A20. The last term N20 would be equal to A20. According to the question, A20 is the number of fishermen who caught exactly 20 fishes each. So the total fishes caught by these fishermen would be equal to 20 and 20, or equal to 20 A20. Add these terms to get the total number of fishes caught by these fishermen. Here you can see A1 minus A2. Here it is 2 of A2 minus 2 of A3, but here it is minus A2, here it is positive 2A2. So the remaining term of A1 minus A2 plus 2A2, so A1 plus A2 you will get, and here it is minus term of 2A3, here it is plus term of 3A3. So again you will get A3 in positive sign minus 3 of A4, and similarly you will get the higher term, and for the last terms you will get it like 19 of A19 minus 19 A20 with minus sign plus 20 A20. So here also the last term you will get A20 with positive sign. So what series you will get, check it from the given 4 options. The first option having A1 plus A2 plus A3 plus A20. So that is the final series of your answer. You can check it from there, A1 plus A2 plus A3 plus A4, so on, plus A19, A20. So the correct answer of this problem is option 1. A1 plus A2 plus A3, so on, plus A20. Friends, you can download this paper in PDF form from the Google Drive link given in the description below. Thanks for watching this video. Keep practicing. Wish you all the best for the exam. Please subscribe this channel, Please share it with your friends and don't forget to tap on the bell icon so that you can get notifications. Thank you.